Hi, this is Martin King with Legacy Chillers. I'm one of the senior design engineers here. This is part of our Smart Drop series, and today we're covering a question by Max in Milwaukee, Wisconsin. How you doing, Max? Thanks for the email submission. We're going to be covering the flooded condenser. We're going to talk about how it operates in a process chiller application, and Max is in the perfect climate for it. So let's check it out. Let's see how it works.
So we're going to do a quick review here of a refrigeration system on one of our process chillers that is equipped with flooded condenser, just so everybody's up to speed. So we have your compressor here, and that's going to give us high pressure gas coming off. And on a flooded condenser equipped chiller, you have two paths of this discharge gas to go. We're going to discount the hot gas. That's a separate subject. So the hot gas goes into your condenser. It condenses. It comes out a high pressure liquid. It goes through what we call a head pressure valve, or they also call this a flooded condenser valve or headmaster. There's a couple different ways to refer to it, which we'll talk about in a few minutes. And it goes into our receiver here, out of the receiver to the dryer, through the sight glass, through your liquid line solenoid, your expansion valve. In our case, it's a TXV, into the evaporator, and it comes out a low pressure gas through the accumulator. All of our chillers are equipped with an accumulator, back to the compressor. Okay, so that's the basics that you need to know. All right, so first, let's talk about what this valve does. So I'm gonna flip the screens over here. We're gonna take a look at what this headmaster does, and then we can jump back to the drawing here. Okay, so what we're looking at here is something I've downloaded from Sporlan. All legacy chillers come equipped with an OROA valve. That's mostly what we use on all of our scroll model chillers. You can see here there's a bunch of different types of flooded condenser valves. On some of our larger semi-hermetic units, we use the ORI valve, but a vast majority of our valves are going to be this OROA configuration. And basically how this thing works, it's relatively simple. This is going to be your discharge line. So this is going to be coming from your compressor, okay? This is going to be the liquid that's coming off the tail end of your condenser. And this is going to be the outlet that's going to your receiver. And we'll flip back over to the plumbing drawing here in a minute. So basically these valves, they all have pressure ratings. They have to be rated at the type of refrigerant that you're using in your chiller. In our case, this is either 404A or 407C. We use a 225 PSI valve. That's what it's rated at. So real briefly, I'm going to explain it here, and then we'll cover it again on the drawing. So this valve is looking for the pressure coming off of the compressor to be 225 PSI or more. All right. So if the pressure coming off the compressor is lower than 225 PSI on this particular valve, it does two things. The first thing that it does is it's going to start to restrict your free flow of liquid refrigerant coming off your condenser out to your receiver. So it's going to start to slow down this normal flow of refrigerant to your receiver. Now what that does, and that's why they call it a flooded condenser, it's going to naturally back up the liquid refrigerant in your condenser. And in essence what it does is it's going to take away condenser capacity because it's filled with liquid, and it tends to run your head pressure a little bit higher. So that's why this is a very popular option when you get to low ambient conditions. Okay. Now, once the pressure of the discharge, your flooded condenser is engaged, your compressor is running, the head pressure has a little time to build up. What happens is this mechanism will start to allow free flow from the condenser into the receiver. So this basically turns into a piece of pipe, okay, just a straight through shot. Now, the other thing that these valves do is when you're flooding, so when this pressure here is below 225 psi, It's also going to allow a little bit of discharge gas to flow through this valve directly into the receiver. And the idea of that is if you've got a machine that's been sitting in very low ambient, I'm talking probably 0 all the way down to -20 Fahrenheit. One of the challenges that you have is the liquid refrigerant that's sitting in your receiver has a tendency to get very cold, very over subcooled, and that can cause issues. So what they do here, when your compressor starts, if your head pressure is below 225 pounds or whatever the rating on the valve is, it's going to inject hot gas immediately into your receiver, and that also helps warm up that liquid refrigerant. And we're going to cover some of the things that this does in the drawing in a minute, and it's gonna help performance on what we call a cold start. Okay, so these valves do two things: they back up refrigerant in the condenser, and they also allow a little bit of gas to flow through to the top of the receiver. All right, so let's take a look at the drawing here in a minute. We'll go over it one more time before we complete this session. Okay, so we're looking at our drawing again here. So this puts it in perspective. So we have our compressor here. This is our discharge line, right? So this is coming directly from the compressor into your headmaster valve or your flooded condenser valve. This is your line coming out of your condenser. So this should be liquid refrigerant, and this is your receiver here. So when we go into flooding, which means the pressure at this point right here is below the rating on the valve, it's going to cause liquid refrigerant to start to back up in this condenser, and that will essentially take away surface area, which will inherently run up your head pressure, which is what you want to do when you have very cold conditions. All right. Then the other thing it does is it also injects a little bit of hot gas in this cylinder here, and this is called your liquid receiver, which is going to help warm up the refrigerant that's in here. Now, I mentioned this earlier. What's the problem with cold refrigerant, right? So what ends up happening in long off cycles, this refrigerant gets very, very cold. And when your compressor first starts and you start to push that very cold, what we call over subcooled refrigerant, your thermal expansion valve has a real problem dealing with this. The common problems that you'll run into is low pressure trips. So basically what ends up happening is the capacity that's feeding into your evaporator has too much capacity. So that causes your suction pressure to be abnormally low, which will cause a trip. Okay. So lastly, before I clear this up, we have two types of flooded options on our chillers. We have standard flooded, which is basically what you see here, that's good to about 0 degree outdoor temperature. For extraordinarily cold temperatures, down to about -20, we add an additional feature, and it's called heated flooded. So what we do here is we wrap this receiver with a low wattage heater, and then we wrap that with insulation. And what this does, in the off cycle, our PLC will apply a little bit of heat on this receiver here, which keeps that liquid in there warm, and it really helps out in their long off cycles. Okay, so that'll get you down to about -20, -25 outdoor ambient temperature. Okay, so that is flooded condenser. I'm hoping that this answers all of your questions. All right, well, that's your Smart Drop educational video for today. Thanks again for stopping in and hanging out with us for a little bit. If you have any questions that we can answer for you, please don't forget to submit to our LinkedIn, Facebook, or Twitter feeds. You can also go to our website and submit questions to us there. We're looking forward to working with you. And if you happen to have any process chiller needs, we're here to guide you through the process to a successful project. Thanks again. My name is Martin King. I'm with Legacy Chillers, and I'm happy to meet you.